Good day, viewers. You're welcome again to our online teaching series. Today, we're going to take a look at a very simple problem in physics: motion in a lift. Now, a man of mass 8 kg in a lift moves with an acceleration A. Calculate the apparent weight. This is weight, apparent weight of the man. Apparent weight of the man if the lift moves downward at 3 meters per second square, upward at 3 meters per second square, and it moves at constant velocity. Let's solve this problem together. Solution. To solving this problem, number one, we draw the diagram of the lift. Now, this is the lift, and the lift has a string attached holding it in place, and there is a tension in that string T. And this is the man inside of the lift. The weight of this man is acting downward. It said that the weight of the man is 8 kg. So the weight of the man, the mass of the man is 8 kg. And we know the weight of the man is acting downward. Weight of the man will be equal to mass times acceleration due to gravity. And we know that acceleration due to gravity has a value of 10 meters per second square, and that is what we'll be using. Number one, calculate the apparent rate of the one if the lift now move downward. The acceleration is downward at 3 meters per second square. So we have it that the tension, take a look at it. Here we have the lift, here we have tension T, and here we have weight W. So since the acceleration is downward, the weight minus the tension will be equal to mass times acceleration. Weight is a force, tension is a force from Newton's second law, so force is equal to mass times acceleration. So the tension here is our apparent weight. So the tension T will be equal to the weight minus mass times acceleration. So the tension here will be equal to the weight is mg, mass times acceleration due to gravity, then minus ma. So what do we have here? The mass is given to us as 8 times acceleration due to gravity 10 minus mass of the body 8 times the acceleration 3. So what do we have? Have the tension as equal to 80 minus 24. And 80 minus 24, the tension, that will be 56 Newton. Now, this is the apparent weight of the man as the lift accelerates downward. Number two, what will be the apparent weight of the man if the lift goes upward, is accelerating? Now, in this case, the acceleration is upward. So we still have the diagram. This is the weight of the mass. Here the tension T, and here we have the weight, mass, W, weight equal to mass and acceleration due to gravity. Here the acceleration is upward. So the tension minus the weight will be equal to mass times acceleration. The tension T will be equal to mass times acceleration plus the weight. Tension will be equal to mass is 8 times acceleration 3 plus the weight of the man is mg. And mg, that will be equal to m here is 8 times 10. So we have the tension as equal to 24 plus 80, and that will be equal to 104 Newton. So that is the apparent weight when the lift accelerates upward. And number three, we are told to calculate the apparent weight when the lift moves at constant velocity. So the lift is moving at constant velocity. We know that at constant velocity, acceleration A is equal to 0. So if acceleration is equal to 0, if the lift is going upward, the apparent weight, the tension, will be equal to the weight of the man. And the weight of the man is equal to mass times acceleration due to gravity, which is equal to 8 times 10, and that is equal to 80 Newton. If it is coming down, the same thing happens. The tension will be equal to mass times acceleration due to gravity, and that will be equal to 8 times 10, which is equal to 80 Newton. We describe this situation as weightlessness. So it means that in a lift motion, when an individual accelerates upward, you see what is happening here. When the individual accelerates upward, a certain amount of mass times acceleration is added to the weight of the person, 80, and that is 104. When it is coming down, look at it. When it is coming down, a certain amount, acceleration times the mass, which is 24, is subtracted from the weight. It becomes 54 Newton. So therefore, in a lift motion, when a body accelerates upward, there is an increase in the weight of the individual. When it is coming down, there is a decrease in the weight of the individual. But if the lift moves at constant velocity, then the weight of the individual remain the same. We describe the situation as weightlessness. In our next class, we'll do more calculation on this. Bye for now. Please, if you have any question, just drop it on the comment section. Bye for now.